Let's just level set and understand what a Terraform provider is and how it works. So if you're watching this, you probably have used Terraform. You've written some infrastructure as code. You've used Terraform to plan, apply, and destroy your infrastructure. And you've done that with any number of cloud providers. You may wonder, how does Terraform know how to provision infrastructure on I think there's about 3,000 different providers in the registry. So how does Terraform itself know to manage all of that cloud stuff? Well, the provider is the secret sauce. So under the hood, a Terraform provider acts essentially as a plugin. It communicates with Terraform core over RPC and presents the resources and data sources that you can manage with the provider. Terraform providers like Terraform itself are written in Go, and they themselves are going to rely on a client library, which is the piece of code that's going to communicate over HTTPS with your target API. And the client library will handle the details of doing things like connecting and authenticating, maybe handling some of those low-level errors like an HTTP connection error, and other things like marshaling the data that it gets back in whatever format from whatever the API is. And then the provider itself is going to use some standard Terraform libraries that we're going to be looking at today to communicate back to Terraform to, again, say, here's the resources, here's the state that we got from the API call, here's what happened when we created your cloud resource, and the results of that. Again, that's a very, very high-level flyover, but we're going to dive into the lab and talk about how to actually do it. So, how and why would you create a provider? I think there's probably three main use cases if you're considering creating your own Terraform provider. You may want to update an existing provider. As I mentioned earlier, there's 3,500 plus providers in the registry, and each of those providers is working with the upstream cloud provider that's adding new features, capabilities, making changes, and of course all code has bugs, so there might be bug fixes and updates that you could contribute to an existing provider that way. So the first step of knowing that is knowing how providers work and knowing how that code works. One thing I want to note here is that the framework that I'm going to be using today is the newest framework that Terraform offers. Existing providers may still be using an older framework called SDK v2, and it's just got some different semantics and some ways of handling data that are maybe not so ideal, which is why we created the framework in the first place. But conceptually, SDK v2 providers are going to work essentially the same way as framework providers. It's just something to be aware of if you're tackling an existing provider that it may not be using the exact same library that we're going to look at today. The other case that you might think of is you're ready to create and publish a new provider. Maybe your company is doing a new product launch and you want to support your customers to be able to manage that product with Terraform. Or maybe you're working with an open source project that doesn't yet have a Terraform provider, and so you're ready to create one, again, to manage the resources that open source project provides. And then the third case, I think, is a lot of companies now are having internal applications that provision cloud resources or private cloud resources within your own data center, maybe. And so you can develop a custom provider to allow you to manage, or to allow your users, your end users, to manage those applications with Terraform. And then you can use Terraform's private registry to distribute those providers internally, again, for something that's not available, widely available externally. So let's talk about the lab scenario that we're gonna look at today. Again, you're going to be able to write infrastructure as code to plan, apply, and destroy configuration. And in this case, the scenario is going to use a fictional HashiCorp application that's going to be all about provisioning coffee, which is very important for a lot of us developers. And as part of this scenario, we're going to be looking at a lot of files, and I am going to be moving around a lot. So just to orient ourselves a little bit, the entry point for any provider is the main.go file, and that's going to run that server, as I mentioned earlier, that's going to communicate with Terraform core over RPC. And then your provider and each of your resources and data sources will have their own file as well as tests, so you can make sure that your provider works correctly. And again, the provider is going to be written in Go. We're going to write the provider in Golang. We're going to be using Terraform to try out the provider as we develop it. But another thing that you're going to need before you develop any provider is the API you're going to be provisioning infrastructure with, as well as a client library that interacts with that API. And again, that client library is going to be handling some of that low-level stuff like connecting, authenticating, things like that. So you want to make sure you have a working, tested library that you can use as a client before you dive into the before you dive into the provider development as well, and of course documentation for that. The provider framework is available from HashiCorp, and that's going to provide the libraries and tools that help you write your provider so that it can communicate with Terraform core. And then the third thing we're going to use is provider scaffolding, which is really just an example GitHub repository that we recommend you use as the starting point for your provider development. And that's going to include some examples and boilerplate files, and really get you off to a good start with your provider development. I think I got about 60 minutes for this, so I'm just going to dive right in, and we're going to start developing our provider. So here's a little QR code and a link. I'm going to be following along with these tutorials, which if you're following along with this lab at home, you can do as well. And these are some of the steps that we're going to get through during the scenario. So I'll give you a moment to load up that link, QR code, whatever. You can also search for plugin framework on our developer website, developer.hashicorp.com, and you'll get to this tutorial as well. So before I dive into that, I'm just going to check in with Brian and see if we have any questions before we get to writing some code.
So I haven't seen anything yet, but I actually had something I was a little selfishly interested in, which is I've seen the SDK a little bit. I haven't used this new plugin framework. Can you talk a little bit about the differences and the advantages of the new framework?
Sure. So the framework is really going to help you write your providers in a more consistent way. It has some improved logic for handling data types, both basic data types like strings and ints and things like that, as well as letting you write your own custom data types, which will, if you're using maybe a little bit more of a complex scenario, that way you can write your provider in a consistent way, even if the data type is a little bit unusual or you want to do some validation, like if we get to it, we'll look at validating a timestamp using ISO something. I can't remember the name of the date format right now, but things like that. So, and also, some logic for generating your documentation and for writing unit tests.
Very cool.
Great. All right, so let's go ahead and dive right in. I've got our tutorial open here right now, and for those of you following along at home, I'm going to be running the commands directly from the tutorial, so don't feel like you have to follow my typing or anything like that. You can just open up this tutorial, open up your terminal program, your text editor, and just follow along. So the first thing we're going to do whenever we start new provider development is we're going to start from this scaffolding framework repository, and that is a little bit small, so I'm going to zoom it in a little bit, and pull requests, great. So this scaffolding framework is going to include, like I said, some boilerplate, some examples. Your actual provider code is going to go into this internal provider directory. And it's got things like makefiles and some GitHub actions and things like that that will help you actually publish your provider to the registry when we get there. So I'm going to get started with this by copying that command, and let's clone that framework repository, and we can look into it real quick, and it's got those files that we just saw in the web browser. Now the first thing we want to do with this scaffolding is we want to rename it to whatever our provider is going to be called, and by convention we recommend that you call it Terraform-provider- whatever. In this case, that fictional HashiCorp application. So I'm going to rename that directory, change into it, and again the name of the module is going to be Terraform Provider Framework Scaffolding, some combination of those words, Terraform Provider Scaffolding Framework. So I'm going to use this Go command to rename it, again the same name, Terraform Provider HashiCorp. And we'll just make sure that our Go modules are installed, and it's downloaded those for us. And then we're going to start looking at the code. All right, let's make that a little bit bigger. And we don't need that. So again, I've got my editor open to the same directory that we just cloned, and the entry point for our provider is going to be this main.go file. And again, this is using the generic name for the scaffolding framework. So I'm just going to replace that with the path that we're using here, Terraform Provider HashiCorp. And whoops, let me arrange those desktops real quick. That's better. Okay, so that has gotten our provider named correctly to our HashiCorp provider. The next thing I want to do is I'm going to set up some Docker directories and files so that we can run a version of our HashiCorp API locally. Again, in development, you probably should have a local version of whatever API or a test version that you can develop against. Developing against production is probably a little bit painful where you're creating real resources and things like that. So we are going to make that directory for our Docker Compose, and I'm going to create 2 files in it. And I'm not going to dive into the details of these files too much. This is essentially just running the database and the API, again, for this completely fictional HashiCorp application. So let me find the right directory. And I forgot the file name already, conf.json. And again, a little blob of JSON to tell Docker to run our database on port 5432, etc. And the next part is our Docker Compose YAML file. And I'm going to create that, again, in this Docker Compose subdirectory. Docker compose.yaml, and just again paste in this this configuration. Again, just to be clear, however you're running your API might differ from the Docker method that we're using here, but regardless, you want a development API set up to develop your provider against. And so let's look at the provider type itself. Oh, actually, I went a little bit fast there. Let me back up and look at the rest of our main.go file before I dive into the provider. I'm not going to read all these comments here, but essentially main.go is, again, just your entry point, and it's going to serve your provider and make it available for Terraform over RPC. That's going to separate the Terraform core executable from the provider executable. Maybe your provider has a bug in it and crashes. We don't want to have Terraform crash just because a provider maybe has a bug or something like that. So it's a completely separate application communicating over RPC. And now we can go into our provider file. And again, with the scaffolding that we're looking at, this has a lot of good examples and documentation. So when you're developing a new provider, read through this and use this as a starting point. For our demo today, I'm just going to select all and replace it with a good starting point for HashiCorp. And all right. Before we move on there, I'm just going to touch a couple of key points in this provider.go file. We are going to use this provider interface from the framework. And it's just going to make sure that at the compile stage, I guess, Go is going to ensure that our provider actually satisfies everything in that provider interface. We got a new function, so we can make a new instance of our provider, and then just a structure that defines things that we need to know about the provider. Right now, just version. This type name, in the metadata function, this type name is going to be important because it's the name of your provider, in our case HashiCorp. It's also going to be part of the name of all of your resources and data sources that you define within the provider. So if you've used AWS's provider or Microsoft Azure's provider, it's AWS underscore whatever. Today it's going to be HashiCorp underscore whatever our data source or resource is. And then schema is going to define the attributes that are available on your provider. We'll look at that in a little bit more detail later. And then the configure method is going to actually set up the provider, anything you need to actually get the provider running. Usually authentication. So your provider needs to authenticate with the API, probably like a host name, maybe a port, password, username, that sort of thing. That authentication is going to happen in the configure method. And then, as you probably know, providers, the main point of providers, I guess I'd say, are the data sources and resources that the provider implements. So those are going to get defined here, and then we'll define the actual implementation of those in separate files. Again, we'll get into that in a little bit more detail in just a few minutes. Okay. So again, we're going to use the example from the tutorial that is going to set up our HashiCorp provider in such a way that we can test it locally. So I'm going to find main.go, and this entire main function I'm going to replace with the one from our tutorial. And again, you can get into the comments in a little bit, but this address, generally the address is going to be registry.terraform.io, but for our local development, we're going to call it hashicorp.com/edu HashiCorp. So it doesn't have any chance of conflicting with a registry provider, again, while we're doing it, while we're developing it locally. All right. And so this has been a lot of code that we've cut and pasted into different files. And so I've done this a few times in practice, so I don't think I made a mistake, but it's very easy to make a mistake, and we want to catch that as early as possible. So we just want to run the provider as is and make sure that Go can compile it and all that good stuff. That'll also make sure that I've got Go installed and things like that. So we're going to get an error here but it's just going to be an error from the framework saying, this is a plugin, you're not really supposed to run it directly. But we do know, since we got here, that our code, main.go and provider.go, compiled correctly. I didn't put any egregious typos or anything in there. So if you're following along and got an error at this point, then you want to take a pause and find out what happened. Probably most likely a typo. Maybe you don't have the right version of Go installed. Maybe you don't have Go installed at all, or whatever. And just make sure we can execute the provider. So now that we've done that, the next thing we want to do is, again, we want to be able to have a nice rapid development cycle. So I want to be able to write some code on the provider, install it, and then run Terraform using that provider to get like a real world, this is how it's going to work when it's run by your users. So these instructions are going to be different if you're on a Mac versus Windows. And long story short, we're looking for our GoBin environment. This is where Go binaries are installed. And I haven't set up anything special for Go, so I don't actually have a GoBin environment installed. If you do, you want to use that value. And if you do not, you're going to use the default path, which is on a Mac /users, your username, GoBin. So get that path ready, whatever it is. If you're using Windows, again, the instructions for that are there. But what we're going to do is we're going to use the Terraform RC file to override the provider. And this is something that you're going to use during provider development. So let me open that file, Terraform RC. Right, and as you can see here, I've already set this up, preparing, but you're going to copy and paste the code from the tutorial and just replace that path. Again, if you're using a Mac and don't have GoBin set, it's going to be users, your username, /go/bin. And let's go ahead and install the provider. And again, with the scaffolding, it's set up all the make files and all the good stuff that we need to set that up. We don't have to do any of that manually. So we'll install it. No news is good news in this case. So let's write a little bit of Terraform configuration to refer to our provider. Let me make that directory. So under examples, which already exists, I'm going to create provider install verification. And as we do our provider development, it's a good practice to go ahead and develop these examples as you go. You implement a new data source, a new resource, make an example for it and run it, just like I'm about to run this. And later on, when you're generating the documentation for your provider, you can just include those examples in the documentation for your users. So they're starting with, anyway, the same Terraform configuration that you tested the provider with. So we made that directory, and now within it, I'm going to make a main.tf file. Let me copy that, and let me find the right directory. Examples, provider install verification, and I'll create a new file there called main.go, main.tf. Because it's Terraform configuration. So this is, I guess, the minimum viable Terraform configuration to use our HashiCorp provider, just like you're using a provider from the registry. In this case, remember that string that we talked about earlier, that's going to be the name of our provider, again, so it doesn't conflict with any real providers in the registry. Or if we're working on a provider that we're going to publish, it doesn't, we're making sure we're using the development version. The provider name is HashiCorp, and we're going to be talking about a data source in just a few minutes that's going to list out the coffee drinks, the types of coffee drink, whatever, the coffees from the data source, just an example. So we've got our Terraform configuration. Now we can run Terraform commands. And again, just to connect the dots, I know I'm going super fast. So because we set our developer overrides in Terraform RC, Terraform is going to find this provider or match the provider name, and it's going to look in my local Go bin rather than trying to install it from the registry. So we can now run a Terraform plan. And we'll get an error here. This is an expected error. This is okay. So we're going to say, hey, provider development overrides, or Terraform is going to tell us, I guess, what I just said. We're overriding our provider for local development. And then it's going to say, the provider doesn't know about this data source you're talking about because we haven't implemented it yet. So that's going to be our next step. So let me go back to our, I guess, root directory of our provider as we move on to the next step. And again, these tutorials, there are 11 of them. I think we've only got probably 45 minutes left. So we're not going to get all the way through this in this session, but we'll at least get you on the on-ramp, and you can follow the rest of the tutorials from home. So let's configure our HashiCorp's client. And those are the steps we're going to take. The center of any provider, maybe center is the wrong word there, any provider block you have is going to potentially have attributes, again, to configure where's our API, what's our authentication. For this example, we're going to be using a username and password. Don't tell the Vault folks, just kidding. But just for a development example, just username and password are nice and easy for us to develop our provider against. So this is going to be going in provider.go. So let me open up that file, internal examples provider.go. And again, this schema function, we're going to see this a few times. Each provider, data source, and resource will have their own schema function that returns the schema of the provider, the things that you can configure via attributes. And again, these data types, schema.attribute, schema.stringAttribute, those are all coming from the provider framework, which we are importing up here. And that's going to give you a nice consistent way to define your providers. This one's going to have a host, optional, username, also optional, and a password, which is both optional and sensitive. If you've ever interacted with Terraform and you do a Terraform plan or a Terraform output and it says this attribute is sensitive, that's how this is implemented. Back up. This is how that is implemented within your provider code. So I'm going to make sure to save that file. And just moving on to the next step. The next part is the schema allows Terraform to understand what the attributes are, but within the provider code itself, we need a model to store and to marshal and unmarshal, like whatever data it is that we're using. So I went a little fast there. Let me back up. I'm taking this provider model again from the tutorial example. It doesn't come from some magical place. And I'm just going to paste that in there. It looks like that worked. So our model is going to say, okay, it's a string. And this little Terraform SDK is referring to the framework is going to match our host username and password attributes as host username and password parts of this Go struct. And the next thing is we need to actually implement the configure function that's going to check to make sure that we have the required attributes. In this case, we need all three. You might have multiple authentication methods. Maybe you can authenticate with a token or something like that. you would also implement those authentication methods in here in this configure function. So again, our example started with an empty configure function, so I'm going to replace that with a bunch of Go code. And let's go back up to the top. And essentially, we're going to say, for this example, we're kind of going to do a little bit of two passes at it, just to say that maybe we got an error from the getting the configuration. That's going to get our Terraform configuration from this block here. We'll fill that in a moment. And we're going to verify, okay, did we have those three attributes? If they're not there, then we've got a little bit of a different problem. We're going to allow users to set those as environment variables. Again, most Terraform providers have that as a method. And then whether we got it from setting it explicitly in our Terraform files, which again, you probably shouldn't use a password in your real Terraform configurations, or as an environment variables, or whatever other authentication method our provider is going to support. We're going to now check to make sure, did we get the required attributes, host name, username, and password. And we can print out a nice error message for your end users if they forgot to set any of those things. And then finally, well, maybe not finally, almost finally, we're actually going to create a new instance of that client. Remember earlier I talked about having an existing client library. This is creating a new one of those, and it's going to pass in, again, host, username, password, whatever other authentication options your particular use case provides. And if that didn't work, hopefully our client is good about producing good error messages. So we're going to just wrap that and say, hey, something went wrong and the provider doesn't know how to deal with it. This is an unexpected error, and we'll just include the error message from your client library. And then when we implement our data sources and resources, they're going to need access to that client that's already been configured, authenticated, ready to go, so that each data source and resource can make whatever calls to the client and then ultimately to the target API. So we've set all that. A little scrolling there. We need to update our imports. Now we're going to be importing, again, this client library. This is something that comes with the HashiCorp's demo application, so that you can follow along and have some real responses that Terraform can interact with. So I'm going to add that to my import statement, and just for ease of use, because depending on what IDE you're using, it may do some automatic magic stuff with your imports. So that's why we're just going to replace it en masse. So we have a good starting point, even if your IDE is helpful in that way. Now we need to actually download the client to our local machine. So let's do that. And that went pretty quick for me. It might take a moment or two for you to download that for the first time, but it's a pretty small library, so I expect it should be pretty quick. And again, just go mod tidy, make sure all our dependencies are installed and correct and things like that. And again, this is, I guess, the second crank of that development cycle of, okay, we made some changes, let's install it and try it out. So we've installed our provider locally, and the next thing we're going to do is we're going to start that service. So maybe you already have a development instance of your API running, but for HashiCorp's, we're just going to run it locally with Docker. So Docker compose up, and On my machine, this should go fairly quickly because I've already downloaded the images and things like that. That might take a couple minutes for those of you following along at home. So I'm going to fill the dead air by turning to Brian and asking if we have any questions from the chat.
Yeah, I think we have a number of people that have been following along. They've been asking for the links to the tutorial, links to the scaffolding framework. So I'll keep dropping those in the chat.
Okay.
In the meantime, you mentioned a couple times around having a separate client library from the provider and not putting all that client logic into the provider. Can you talk a little bit more about what are the advantages of using that pattern and why you should do that?
Yeah, so I think fundamentally it's a separation of concerns issue. It's we kind of bandy that term around about, I guess, but it really does matter because as you're developing your provider, you don't want to have to wonder, okay, is the bug in my provider code? Is it something with like how I'm communicating with Terraform, or is the bug actually in how I'm like making the API calls and getting the data from there? So that's why we recommend before you start working on the Terraform provider, you have that known working client library that hopefully has its own tests, and you can just run independently, and you could write any kind of Go code against that library and make sure it works first. And then we can have Terraform and know that if I make a bug, if I produce an error here, it's going to be in my code, not the HashiCorp's code. I know that code is good. It's the code that I'm writing now is the only code that I really want to discover bugs in, not something that I'm relying on.
Makes perfect sense. Thank you.
Okay, great. Any other questions before we keep going?
No, I think we're good.
Okay, great. Thanks, Brian.
Hey.
Okay, so here in my first terminal window, I ran Docker Compose up. It kind of put a bunch of stuff on my screen about starting databases and loading some example data. Again, that's very implementation specific for our HashiCorp's example. So I'm not going to dive too much into that. I'm just going to open up a new terminal window to continue development on. And I'm going to make sure that's in our provider directory. So we can have our provider running locally and then continue development and testing from here. So we started everything. Let's make sure the provider is working. I can kind of see the output here, but the HashiCorp's API has a very simple health check kind of system to make sure it's running and we can reach it and it's on the right port and all of that. So this curl command should return with an OK. If it doesn't, then maybe take a break, make sure nothing is running on that same port, make sure Docker commands worked and all of that. Just make sure nothing went wrong there. So we're going to create a test user so we can test out that configure method and the authentication of that. And that's just going to be another curl command, creating a new user with username education and the password. Don't use password as your password. Except now. This one time, we won't tell the Vault people we're using just boring passwords. But we do have a nice token here that I'm going to copy. And again, authentication-wise, this is going to let us authenticate with the HashiCorp's API just when we're running some commands locally. For the Terraform configuration, we're going to be using that username and password. All right. So let's implement a data source. What we really are. Let me back up. Our next goal is to make sure that our Terraform provider can authenticate with HashiCorp's and that whole cycle works. However, Terraform isn't going to try any of that if the provider isn't providing anything. So we're going to create a really quick temporary data source just to make sure that the provider authenticates. So I'm going to call it coffeesdatasource.go. And let me make sure it goes in the right place. internal provider and coffees data source.go. And I'll paste the code from the example here. One of the lovely things about live demos is even though you practice them 100 times, you see all the little typos and mistakes. I'm just noticing that this path is wrong. Ignore that. It goes in internal provider. And if you're watching this after today, I will probably have fixed that. But regardless, all of our data sources and resources are going to go right here in this directory. Coffee's data source is going to give us a list of coffees eventually. So here's that provider name I mentioned earlier, HashiCorp. So the data source name is going to be HashiCorp's HashiCorp _ coffees. Let's go there. And I'm not going to get too much into the implementation of the data source right now because, again, we really just want to do this to make sure that authentication works. We'll look at how to actually implement a data source in more detail in just a few minutes. Now we need to tell our provider about the new data source. And so let's go to provider.go. And again, this down here way at the bottom, this data sources function is just going to return to Terraform a list of the data sources that our provider implements. So that way Terraform can match everything up and find the data source that we want it to. And with those two bits, we can install the provider again. Install the provider again. Okay, there we go. And let's make sure that it works. Remember, we created this provider install verification directory just a few minutes ago with that, let me just look at the file from here, with that main.tf file that's referring to the data source that we just implemented. Again, we're going to run and expect an error, a little bit of a different error from earlier because we haven't set up any authentication with the provider. So let's run a Terraform plan. We're going to get an error, but that's okay. Well, I should have said 3 errors. So these are the errors that we just looked at in the configure method saying, you need to set the host name and the username and the password. So oops, let me get those here. And again, earlier we looked at ways that you could set those either with environment variables or directly in the provider block. So let's try it with environment variables first. So there's our host, localhost 19090, that username and password that we set earlier when we created the example user. And then it's going to run Terraform plan with those environment variables set. This same message, but this is really great news. So this tells us that Terraform was able to connect to our provider. It found the HashiCorp's coffees data source. It ran that function that we just created, and it didn't get anything back really yet because we're just stubbing out that data source to make sure that this full cycle worked. And of course, since there's no resources yet, there's no configuration changes to make. Just pausing here for just a moment, we've done the full cycle of, hey, we authenticated, we found the data source, we made the API calls. This is really, we're ready to start rocking and rolling on our provider development. Or, maybe not rocking and rolling, but it's still fun. Let's make another example. So just to orient ourselves, I'm in that examples provider install verification directory. I'm going to make another directory next to it in the examples directory called coffees. It's going to test out our data source and move into it. And we've got another version of main.tf. So let me create that in the right directory. And for For those of you following along, just so you know, preparing for this, putting the file in the wrong directory was the #1 thing that I ran into testing this. So I'm triple checking. I'm in the coffees directory, main.tf, and this time, this example sets those attributes right on the provider block, just to make it a little bit easier to run that cycle of plan, apply, test, all that, without having to set those environment variables, worry about them. It also shows that you can have multiple ways to set those attributes, which is pretty common for most of your providers. You're probably used to setting them with environment variables. And then we have our data source again, and let's run another plan. Okay. So again, nothing really exciting there. So far it's just essentially the same configuration we just looked at, but we know we have something to test against. The next thing I'm going to do is, now that we know we can authenticate, I'm going to remove that that example data source, and we're going to recreate it for real. Just so we don't have to dive into all the implementation details of a data source right away. So again, finding the right file name, internals provider.go. There we go. And just to make sure we all get to the same point at the end of this tutorial, we're going to reset what we did and install the provider again without that data source. All right, and we're ready to go on to the next tutorial about data sources. Brian, while I'm doing that, I'm just going to check in with you again. Do we have any questions from the audience about configuring, authenticating, all that good stuff?
So far, just a lot of great feedback. People are seeming to enjoying this this Learn Lab. I was kind of curious about testing. I know I'm probably jumping the gun a little bit, and I really want to make sure we don't take up too much time. But is that something that's supported? Is that something that I can even do with my providers?
Yeah. So the scaffolding that we used earlier has some tools and things set up for testing, and we're probably not going to get time for it because we've only got 60 minutes. But about 5 tutorials from now, we're going to implement testing for the first time.
All right.
And then documentation, which I'm a fan of.
Yes.
So yes to testing. Just keep following the tutorials, and you'll see some good examples of that. So again, we're recreating the file that we just created, but with some real implementation this time. So coffees data source.go. Oh, and those test files, they're going to live right alongside our regular files. I had a diagram earlier that showed that. As you develop, you create a new data source, you write the test for it at the same time. For test-driven development, you write the test first. So here's our real data source, or at least the starting point from it, where we're going to return our coffees, but this time we're going to do it for real. So let's add that back. And I know this seems like we're just redoing what we undid. For the purposes of the tutorial, we really want to make sure that the authentication part works before we move on to implementing the data source. So this is a good starting point for us here. And the first thing we need is access to that client. Remember, we already know that the client is configured and authenticated, and we made it available to our data source, but the actual data source needs access to it. So we've got a type for, whoops, I meant to replace our data source type. And in this case, the one thing it's going to know about, excuse me, I'm glad there's water here. So the one thing that our data source needs to know about is the HashiCorp's client. It needs to call out to that client to make our API calls. All right. And we need to import that. And again, your ID may be super helpful here, but I'm just going to replace the entire block here and include that client library. And the next part we're going to do, before we go too fast here, is we're going to use a couple of interfaces. Sorry, I'm remembering the Go terminology. A couple of interfaces from the Terraform framework that are going to ensure that our data source is it's a data source. It's also a data source with configure that essentially lets you have that configure method. Some data sources might not need configure, but really anything that's calling out to an external API or holding any state inside of itself probably needs that configure interface. But the framework makes those separate, so you don't have to implement the configure function if you don't actually need it. That's the data source, and then with configure layers on top of that, the configure function as part of the interface. So let's implement the configure function. And the only thing we really care about here, where am I going to put that? Of course, Go doesn't care where you put it, but just for consistency, I like to put it right under our type definitions here. So that configure function, we're going to make sure that the provider is correctly initialized. Pretty rare that you would get to this point, but maybe something went wrong with the provider configuration and we don't actually have access to that client. So we want to fail early here if that does happen. You might include other verification here or other configuration steps, like maybe you need to do a little bit of a setup for part of your application that the rest of the provider doesn't need to worry about. Only this data source needs this particular thing set up. You would put that here as well. And we talked about provider schema. Each resource and data source will also have their own schema that's going to define the attributes that are associated with that data source. So again, our example configuration has the function already, so we satisfy the interface, but I'm going to replace that with some actual implementation. So this is going to be I guess I would say Terraform's understanding of the data structure that we're getting back from our data source. It's going to be a list of coffee objects, and each coffee object is going to have a bunch of attributes inside of it, ID, name, etc. And then one of them is going to have even more nested data inside of it. Again, you've used Terraform if you're watching this, I assume. So you've seen whatever you get back from the API, you need to kind of marshal and unmarshal that into a nested data structure for Terraform to understand. So you might get whatever data structure back from the client. That's going to get stored in the model, and then that's going to, Terraform will be able to match these up by the name of the attribute. So your Go data type matches to your Terraform data type. So that's going to be, in this case, I think there are 3 different models. One for the list of coffees, one for each individual type of drink, and then one for each ingredient in each drink. So I'm going to put that up here with the rest of our types. And that didn't format exactly correctly. I'm not going to worry about that right now. Well, apparently I can't select things. Almost. There we go. All right. Shouldn't have worried about it. Da, 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 da. So yeah, so this is going to be the model. So this is the Go data structure that's going to store the data about that we get back from the HashiCorp client. Let's get to that. Again, I'm going to make sure that our imports are correct. We're also using this format library. There's, I think, a string formatting that we're doing somewhere. Yeah, sprintf. So we need that. We need to import that as well. As you may know, Terraform providers and Terraform follows that plan, apply, destroy life cycle. Our client library is going to be thinking in terms of create, read, update, destroy. Since it's a data source, the only method that we need to implement is read. We're just, data sources are read-only. Resources will need generally all four: create, update, read, destroy. Here's the, I guess, stub read function that we're going to replace with some implementation. Again, I don't want to get too into the weeds on these implementation details. But first things first, if there's an error, we want to error out early. So this is going to be an error from that client library. Let me back up a second. We're going to call the client library. It's going to have a function to whatever the equivalent of reading the data source is. In this case, it's called get coffees. And then if that client call errors out, we'll provide an error message. And again, this is where separation of concerns. Our client library will hopefully be giving the user a nice detailed error message telling them exactly what went wrong. And then we're going to take the data directly from the client library, and we're going to do a little bit of conversion, essentially converting from whatever the type is under the hood to a type that Terraform can understand. These are from the Terraform framework for strings and ints and floats and things like that. And then each time we're going to append the new coffee to our list of coffees model. And then finally, we're going to take that and we're going to set Terraform state. Again, Terraform basics, everything goes into Terraform state, including the results of our data source. And then occasionally we might get an error there, so we want to respond appropriately to that error. So let's turn our development crank one more time by installing it. Okay, we've got an error. This is, I bet I put the file in the wrong directory. I did, yep. So like I said, that is, for me, the #1 source of errors is putting files in the wrong directories. I accidentally put it in internal, should have been in internal/provider, coffees data source. Make sure that's saved, run our Go install, no errors is good news. And let's verify that real quick. So we're going to go into that directory. So we have the coffees. Let's create an output value so we can actually get some results on the screen. So let me find examples coffees main.tf, and I'm going to add just the output value there. Again, just this is what I should have selected. So we're getting the data, and then we're just going to output it, the whole thing. And let's run Terraform plan. And hey, now we've done, we've gotten data back from our client library, which made a call to the HashiCorp API, and got some data back. So that's implementing a data source. Implementing a resource is that plus a little bit more. So since we're creating and deleting and updating resources, you need to implement the rest of the CRUD functionality: create, read, update, delete. However, I think we're running right up on time, so I'm not going to have time to walk through that with you. But we've got these tutorials out here that you can follow along at your own pace, and implement some logging, which is good, and then implement some real resources. And at the end, you'll see how to publish your provider to the registry. So Brian, any further questions? And I think we've got a minute or so left.
Yeah, I think we have time for one question.
Go ahead.
Someone had asked, are the Terraform framework defined types in the data model different from the schema defined data types?
They are, I would say, equivalent. I'm not sure if I can pull up the example here real quick, but the schema data type is going to be things that define how the attributes on your resource or data source block work. Is this a computed attribute is a big one for data sources, or for resources where you can't set the attribute, but you get it back when you create the resource, whatever it is. You create a resource in your cloud provider, it's going to set some things like when it was updated or created and a bunch of other information. So these data types are about how Terraform is going to interact with your configuration. The model data types are going to let you map the results that you get from your client library to your data model. And then again, just by name, Terraform is going to match those up. So you don't have to explicitly say, okay, now set this attribute, now set that attribute. It just matches your model structure to your schema.
Perfect. Okay. Makes sense. Thank you.
Great. Thank you. Any other questions?
Real quick, we got 30 seconds maybe. If I wanted to take a provider that I have on the previous SDK and migrate it, do we have any materials for that? Any documentation?
Yeah, so we do have documentation for that. Now I've forgotten how to manage my windows. But at the links to the each of the tutorials, at the bottom of each of the tutorials, there's going to be links to our documentation that talk about the SDK v2, Terraform framework, and somewhere in here there is a migration guide that I'm not seeing right now. It's here somewhere. I've just forgotten.
As usual, read the docs, right?
Yes, definitely. Oh, there it is, right in the middle of my screen, migrating to from the SDK. All right, great. Thank you so much.
Thank you.